Hi, in our previous video we explored the core skills required for solving equations where the unknown is located on one side of the equation. Today we are going to investigate how to solve equations where the same unknown is on both sides of the equation. So let's begin. The first question we are going to explore is where we have on the left hand side of the equation 5x plus 2, which is equal to the right hand side of the equation of 3x plus 8. We can actually view this same equation here on the left on the set of scales I have, where the 5x is represented by these 5 blue values on the left hand side, plus the 2 units of the orange values, with the 3x values on the right hand side here in blue, and the 8 units in the orange here. As you can see, at the moment our set of scales is balanced. Our primary goal here is the same as the first video. We want to isolate the x values only on one side of the equation. To do that here, we need to somehow remove the x values from one side of the equation, or visually remove it from one side of the scales. To achieve this on our set of scales, we could subtract 3 of these x values here in blue from the right hand side. However, if we remove those 3 blue values, it would unbalance our scales. So we'd have to remove 3 blue values from the left hand side to keep the scales balanced. As you can see here visually, we're left with on the right hand side 8 units in the orange. On the left hand side we're left with 2 of our x values and 2 of our unit values. Algebraically, we can express this and show our working out by subtracting those 3 x values from the right hand side. If we've got 3x, subtract 3x on the right hand side, that'll cancel each other out and will leave just our 8 units. However, to keep things balanced, whatever we do to one side, we must do to the other. So if we remove 3 of our x values from the left hand side, it leaves us with 2 of our x values plus the 2 units that were there, and they both now balance. Now, our main goal here is to isolate the remaining x values on the left hand side. To remove the unit pieces on the left hand side, we need to subtract 2 of these, as you can see. However, to keep our set of scales balanced, we would also need to subtract 2 from the right hand side of the scales. Algebraically, we can show this in our working out by subtracting 2 units from the left hand side, but also subtracting 2 units from our right hand side. On the left hand side, we're left with our 2x. On the right hand side, we've got 8 minus 2, which is 6. So as you can see, both algebraically and through our set of scales, that 2 of these x values is equal to or balances out with 6 of our units. Now visually, you could probably work out in your head now that each one of these x values must be equal to 3 of these units. Algebraically, to find that, we need to perform our inverse operations one last time. We've got a 2 multiplied by our x value. The inverse to multiplication is division. So if we divide this side by 2, it'll cancel out and leave just our x value on the left hand side. However, whatever we do to one side, we must do to the other. So we now must divide the right hand side by 2, and 6 divided by 2 equals 3. So we've found that our pronumeral x should equal 3. The advantage with all these questions is we can perform a check step using substitution. If we substitute our x value back wherever we see an x in the original problem, we can check ourselves to see whether we're correct. So we have 5 multiplied by our x value of 3 plus 2 should equal 3 multiplied by x value of 3 plus 8. On the left hand side, 5 times 3 is 15 plus 2 should equal 3 times 3 is 9 plus 8. On the left hand side, 15 plus 2 is 17. On the right hand side, 9 plus 8 is also 17. 17 equals 17, so we're correct. The second question we're going to explore without using a set of scales. On the left hand side here, we find that 2x plus 7 equals our right hand side of 5x take 8. Like the previous question, our first goal is to isolate the x values to one side of the equation. You may have noticed that if we subtract 5 from both sides of the equation, it will remove this 5x value from the right hand side. However, 2x minus 5x will equal negative 3x, so it will remain with a negative x value on the left hand side. There is nothing wrong with this. You can still find the correct solution by doing that. However, for the moment, I'm going to ensure that I keep a positive x value. Therefore, I'm actually going to subtract 2x from both sides to remove the 2x here and remain with our x values on the right hand side. We show this by subtracting 2x here and subtracting 2x on our right hand side here. These two values will cancel out, and on our left hand side we're left with our 7 units. On the right hand side we've got 5x take 2x, which leaves us with 3x, and subtract our 8 units. My next step is to isolate the x by performing the inverse of whatever is on the same side as this x value here. Therefore, because the last thing that I do on the right hand side is subtract 8, I need to perform the inverse of subtraction, which is addition, and plus 8 to remove that from the right hand side. However, whatever I do to one side of the equation, I must do to the other. So I need to plus 8 here on the left hand side. On the left hand side, we have 7 plus 8, which is 15, which is equal to our right hand side. We've still got our 3x, but we've now cancelled out our subtract 8. From here, we need to perform the inverse operation of our multiplication between our 3 and the x. So we need to perform a division by 3 to cancel this out and leave our x value on its own on the right hand side. However, to keep it balanced, we must perform the same division by 3 on the left hand side. 15 divided by 3 will equal 5, so therefore we've found that our x value should equal 5. Once again, we can perform a check step to ensure that the pronumeral that we've found is correct. We do this via substitution. We take our pronumeral x and substitute it wherever we see the x in our original problem. So we have 2 times our x value of 5 plus 7 should equal 5 times our x value of 5, subtract 8. On the left hand side, we've got 2 times 5, which equals 10, plus 7 should equal 5 times 5, which is 25, subtract 8. On the left hand side, we find that 10 plus 7 is 17. On the right hand side, 25 subtract 8 is 17. 17 does equal 17, so we've found the correct solution. Now it's your turn. Here are some questions for you to practice finding the unknown for. Remember that you can check whether the answer you find is correct by performing a check step through substitution. Thanks for watching.